Welcome dear students. I welcome you all for physics class. Okay, so in last class, that is an online class, we had discussed about the physical world lesson. So from that lessons, what is a science, what is the meaning of science in different languages, and then what are the discipline covers by the science we had discussed. After that, what is a physics and what is the meaning of the word physics in different language, and what are the discipline and important physical thrust in the physics also we have discussed. In that, the two main domains, one is a microscopic domain, another one is macroscopic domain. So from that, what are the chapters are included in the macroscopic domain, then what are the chapters are included in microscopic domain too we have discussed. Okay. After that, the scientists who contributed something to the societies and their inventions and the technology which is involved in their inventions also we have discussed. So the scientists all over the world, what they discover, what are the technologies are there behind their inventions, and which countries they belongs to. Moreover, the whole year, that is in the grade 11 and also in the upcoming year grade 12, what are the inventions you are going to learn, all together they are compiled and they given in a tabular column. Okay. After that, we have discussed the fundamental forces in nature. Okay. There are four fundamental forces in nature. In that, first force is gravitational force. What is a gravitational force? Actually, every object in the universe attract every other objects. In the universe over object, no object attract. So the nature of gravitational force is always attractive. But the range is, it is not a short range, it is a wide range. It is in the macroscopic domain. Even in the universe, from the earth to the star, from our star to the neighbor star, our galaxy to the neighbor galaxy. So in the entire universe itself, the gravitational force only there, but the nature is only the attractive force, but it is the weakest force. After that, electromagnetic force we have discussed, but electromagnetic force means it is mainly between the force between charged particle. We have a two charged particle, one is a proton, another one is electron. So if the force between the proton to proton, it is repulsive. Similarly, the force between electron to electron is repulsive, but force between proton to electron or electron to proton is attractive. But gravitational is only attractive, but electromagnetic force is either attractive or repulsive. Okay, and the range also somehow short range, but comparing a gravitational force, it is a short range only. The next one is strong nuclear force. That too we had discussed. The strong nuclear force is the very strongest force of all known force, because everything around us is made up of an atom. The atom contains a nucleus. The nucleus contains a proton and a neutron. So it is a force between proton to proton or neutron to neutron within the nucleus, and the range is relatively very small. It is in the Fermi meter. So Fermi means, what is order? 10 to the power minus 15 meter. So the strong nuclear force is very strongest of all known force, but the range is very very small. Okay, but the electrons are there in the orbit. Okay, but how electrons are held in the orbit? It is due to electrostatic repulsive force. That force also you are going to learn in your 12th standard. Okay, and then weak nuclear force. The weak nuclear force mainly it's happen during beta decay. So during beta decay, it emits an electron and also one positrons. So that is also very weakest force. And then in ascending order, how to arrange the forces also we have discussed. So that from that lessons, you need to go through only the four fundamental forces. That's all. Other than that, you need not to revise. Even in exam point of view also, only you go through the four fundamental forces. And moreover, all these forces, four fundamental forces, you are going to study in the coming years. Okay, both 11th and 12th standard. Okay, now we are moving to the next lesson. It is the units and measurements. So our physics chapter starts from this lesson only. Even in your lower classes, right from 6th to 9th also, you have studied the units and measurements up to 8th. So measurements is everywhere, it's necessary. So everything, if you want to purchase a dress, the measurements is required. With the measurements only, we can build the house. Even if you purchase milk, oil, like grocery items also, measurement is there. So there will use length and mass, the quantity. Okay, there will use the quantity, length and mass. Okay, so measurements plays a very important role in everywhere. Mainly it is used in physics. Okay, so before entering into the lesson unit and measurements, first we should know what is a unit. What is a unit? So what is a unit? So it is a measurement of any physical quantity. First I will write the definition and then explain. It is a measurement of any physical quantity that involves comparison with a certain base arbitrarily chosen and international standard. That is called as unit. Example, you want to measure your height. Okay, you want to measure your height. Your height is 160 centimeter. So in this measurements, the unit is followed by a number. Similarly, you want to measure your weight using weighing machines. You measure your weight. Your weight is 55 kg, 55 kilogram. So the unit is followed by the number. And you want to know, in a running race a student participated and we are counted as it's a relay, and the time taken by the person to reach the 100-meter relay or 100-meter race. In the running race, the time taken, it is taken in 10 seconds or 20 seconds. So it is a number followed by a unit. So what is a unit? So it is a measurement of any physical quantity, whatever may be the physical quantity. It is a measurement of any physical quantity that involves comparison with a certain base that contains the comparison of certain base and arbitrarily chosen and international standard. Then only we can say it is a unit. Okay, and we cannot use our convenience to the unit. There is some standard method is there. Okay, so that also we are going to discuss. After the unit, the next one is fundamental units and derived unit. What is a fundamental unit? And what is a derived unit? What is a fundamental unit? Another one name for the fundamental unit is base unit. So fundamental unit is nothing but it is a unit which is used in the fundamental quantity. Okay, the fundamental units, it's nothing but the unit for the fundamental base quantity. So it is the unit for fundamental or base quantity. It is a unit for the fundamental or the base quantities. Okay, example, the liter. Okay, then mass, the length, the time, the current. So we have some basic fundamental quantities and also we have derived quantities. Similarly, the units which is used to measure the derived quantities is called derived units. Okay, so using the fundamental quantity, the quantity which is obtained by using the fundamental quantity. Okay, the quantity which is obtained by using the fundamental quantity is called derived quantity. So using fundamental quantity, the new quantity is obtained. The new quantity is obtained is called derived quantity. The new quantity is obtained, that is called derived quantity. Okay, so using the fundamental quantity, the new quantity is obtained called derived quantity. Okay, so basically what is a unit? unit na enna nu paathom. After that, what is a fundamental unit or a derived unit? Sorry, fundamental units is also called the base unit. The next one, what is the derived unit, we have discussed. Next one, system of units. What is a system of units? So far we have discussed what is a unit, what is a fundamental or base unit, what is a derived unit. Now only we are entering into the system of units. Okay, there is a system they framed to follow how to use the unit and how to follow some measurements. Okay, to follow some measurements, how to use the units with their quantity. So before framing this SI system, all over the worldwide, they followed the different system of unit. So the first system of unit is CGS system. The second system of unit is FPS system. I'll explain everything. The third system of unit is MK system. So before they introduce SI system, nowadays we are following only the SI system, which means 1 meter na 100 centimeter, and 1 centimeter na it's a 10 millimeter. Abdin all over the world ellame abdi da iruknom. So in a meter scale we know 0, 1, 2, 3, 4, 5 millimeter, 6, 7, 8, 9, 10 millimeter, which is equal to 1 centimeter. So the 1 centimeter is equal to 10 millimeter. So all over the world this is a method they followed in the SI system. But before they introduced the SI system, all over the world the people followed the different system of unit. The first system of unit is CGS, which means centimeter, gram and second. Okay, to measure the length they use the system centimeter. Similarly, to measure the mass they use the system gram. To measure the time they use the system second. Okay, they use the unit second. And another one system of unit is FPS. Similarly, to measure the length, the foot, நம்ம போர்வெல் கிணறு வெட்டுறப்பெல்லாம் ஸோ யூஸ் பண்ணுவாங்களே அடி 10 அடி ஆழம் 100 அடி ஆழம்னு சொல்கிறோம்ல. ஸோ த ஃபுட் டு மெஷர் த லென்த். ஸோ ஃபுட், தென் பவுண்ட், P means P stands for pound, then S stands for second. So foot, pound, second. Here centimeter, gram, second. So third system of unit. Moreover, this is a system of unit they used in the England. Okay, so that is a British system. This one is called the British system. So in the British they use the system foot, pounds again. And MK system is to measure the length they use the unit meter. Then to measure the mass they use the unit kilogram. Then to measure the time they use the system, they use the unit second. So MKS, to measure the length, to measure the mass and to measure the time. So here these are the unit to measure the length, and these are the unit they use to measure mass, and these are the unit they use to measure time. So there is no uniformity. So because in all over the world different people started using the different system of unit. These are the 3 different system of units they used. So there was a confusion. To avoid this and to eradicate all these confusions, finally they brought a common unit measurement system. That system only is called the SI system. Next we are going to discuss about the SI system. So why they introduce the SI system? Because different peoples in the different countries followed the different system of units. To avoid the confusions, they brought the new system of unit to follow uniformly all over the world. Then the system is called SI system. So SI stands for SI. We'll use SI, no? So it is not a sub-inspector. It is a Système International D unit. In French, its meaning is Système international D units. That is the expansion of SI. So when they introduced this SI system, they introduced the SI system in 1971. There was a conference held at France. Okay, the name of the conference is General Conference on Weights and Measures. So General Conference on Weights and Measures. Yes, weight and measures. In 1971, they introduced the SI system. So SI means Système International D Units in French. The meaning, expansion is brought from the French. Système International D Units. So when they introduced this SI system in 1971, எங்கனா France என்ன நடந்ததுன்னா, there was a conference held. The conference name is General Conference on Weights and Measures. Okay, General Conference on Weights and Measures. They adopted the SI system. But what is the benefit of using SI system? Because the advantages of SI system, next we are going to check the advantages of SI system. What are the advantages of SI system? The first one, SI system used decimal system. Okay, SI system used decimal system for a greater accuracy. Precision. Mostly accuracy. For greater accuracy, the SI system is used. That is one main advantages. The second advantages is the conversion within the system. The conversion within the system is quite simple and convenient. So that they introduce the SI system. Okay, these are the domain advantages of following SI system. The first one, the SI system use a decimal system for a greater accuracy, and then to exchange from one value to another value. Example, 1 meter is equal to 100 centimeter. Also we can express in millimeter. Similarly, 1 centimeter is equal to 10 millimeter. So easily we can convert one unit to another unit. So meter into centimeter, and gram into kilogram, hour into minute, minute into seconds. So easily we can convert the system within the system itself. So within the system itself, easily we can convert. So the conversion of within the system is quite convenient and very simple. So that they follow the SI system. Okay. Now from the SI system, we have some fundamental quantity as well as the derived quantity. So what are the fundamental quantity and derived quantities are there? That only we are going to check now. Actually, SI system was introduced in 1971 at the conference, that is General Conference on Weights and Measures. From the conference only they introduced the SI system. So at the time they introduced 7 fundamental quantities and 22 plus derived quantities. So we have 7 fundamental quantity. We have 7 fundamental quantities plus and 22 plus derived quantities. Okay, so what are the 7 fundamental quantities and what is the symbol? How to define this each quantity? All we are going to discuss now. Okay, the first quantity is length. Okay, so now we are going to discuss what are the 7 fundamental quantities and then 22 derived quantities. Okay, now we are going to discuss the 7 fundamental quantities, mainly the 7 basic quantities. We are not going to discuss the derived quantities. Derived quantities we will use later, but mainly we should know how to use the 7 fundamental quantities. So what are the basic fundamental quantities and their name, their symbol and definition. In that, first fundamental quantity is length. So the length. So length, what is the SI unit of length? The name of the unit is meter. So length is measured in meter. So the symbol is small m. What is the definition? Look at the definitions. We know the speed of light. What is the speed of light? Light travels at the speed of 3 into 10 to the power 8 meter per second, which means within a 1 second, light travels at the speed of 3 lakhs kilometer. That we can say 3 into 10 to the power 8 meter per second. But accurate value is not a 3. So the accurate value of the speed of light is 2.99792,458 into 10 to the power 8 meter per second. This is the speed of light. But the round of the digits, how to round off the digits, we are going to discuss afterwards. Okay, at the end of the lessons we are going to know the round of digits and significant figure, all that. So this one they converted into 3. Anyhow, this is the speed of light. So in a vacuum, the light travels at the speed of 2.99792,458 into 10 to the power 8 meter per second. So in that, it is the length of the path traveled by the speed of light in vacuum. So I'll write the definition. It is the length of the path travel by light in vacuum during a time interval of, so from this we can get the time interval. Time interval of, what is the time interval? Generally we know the speed of light in vacuum. ஒரு செகண்டுக்கு இவ்வளோ போகுது அப்படி வேக்யூமில் லைட் வந்துட்டு ஒரு செகண்டுக்கு இவ்வளோ தூரம் போகுது அப்படின்னா இதில் 1 மீட்டர் அப்படிங்கிறது என்னது? 1 மீட்டர். ஸோ ஃப்ரம் திஸ் the 1 meter is the length of the path of the light. So what is the length of the path of the light? That is a 1 meter. So that 1 meter is equal to, so how can we define that 1 meter is equal to, what should come? 1 divided by 2.99792,458 of second into 10 power 8. The 10 to the power 8, if you multiply, then what you will get? The decimal will vanish. 10 to the power 8 போட்டால் இங்கே டெசிமல் போடுவோம். 10 to the power 8 எல்லாம் டெசிமல் பாருங்கள், 1 2 3 4 5 6 7 8. ஸோ அப்போ டெசிமல் வேனிஷ். ஸோ 1 by 2.99792,458 of second. ஏன்னா நமக்கு தெரியும் speed is equal to meter per second. So 1 meter is equal to speed into second. Therefore 1 meter is equal to speed into second. So the speed, 1 meter is equal to, what is a 1 meter? 1 meter is equal to speed into second or 1 by the speed into second. Okay. So this is the definition of the length. So length அப்படிங்கிறதுக்கு definition எதுலேருந்து கொண்டு வந்தாங்கன்னா, we know the speed of the light in vacuum. This is the speed of light in vacuum. What is the speed of light in vacuum? That is denoted by the letter C. The speed of light in vacuum is 2.99792,458 into 10 to the power 8 meter per second. So light வந்துட்டு ஒரு செகண்டுக்கு இவ்வளோ டிஸ்டன்ஸ் ட்ராவல் பண்ணதுன்னா அதில் 1 மீட்டருங்கிறது என்னது? What is the 1 meter? 1 meter is the length of the path. That is 1 meter. The length of the path travel by the light in vacuum during the time interval of, அதில் அப்படியே இன்வெர்ஸ் எடுத்து போட்டிங்கன்னா கிடைச்சது. Okay, so this is a definition of what? The length use பண்ணுற யூனிட் வந்து மீட்டர், அதனோட சிம்பிள் m, and the definition is also given. Now we are moving to the second physical base quantity. The second base quantity is mass. Mass is a very simple thing. What is a mass? Mass, the SI unit name is kilogram. So the symbol is small k, small g, kilogram. What is the definition? In France, there is a physical laboratory. Okay, the name of the physical laboratory is International Bureau of Weight and Measures. So in the physical laboratory, there was a alloy cylinder. There was a alloy cylinder. There was a alloy cylinder. This alloy cylinder is made up of the two metal, because alloy is a mixture of two or more metal, no? So what are the alloys it is made up of? It is made up of platinum and iridium. So these are the two noble metals, platinum and iridium. So this alloy cylinder mass exactly equal to 1 kilogram. Suppose if you have taken this alloy cylinder and you placed on the physical balance, that it won't shows less than 1 kilogram or more than 1 kilograms, which means some milligrams add aayirukadu, some milligrams less aayirukadu, exacta 1 kilogram kaamikum. So they designed like that alloy cylinder, and that was kept in the CBSE in France physical laboratory. So appo France la irukku oru physical laboratory la oru alloy cylinder irukku. That alloy cylinder is made up of platinum, iridium metals. So this alloy cylinder exactly shows 1 kilogram. Okay, so that is the definition of this kilogram. Now moving to the third one, it is time. The quantity is time. The third quantity is time. How? What is the unit used? The name of the unit used is second. Second is the name of the unit used in the quantity time. Now the symbol and definitions we are going to discuss. The symbol is small s. What is the definition? See, nowadays we are following the GMT time and IST time. Already lower classes you may studied Greenwich Mean Time and Indian Standard Time. So இங்கே நம்ம ஃபாலோ பண்ணுற எல்லா டைமுமே the time யூஸ் பண்ணியிருக்கிறது not ordinary clock. First ancient days they used what clock? Water clock, sand clock, sundial. After that they used some machinery clocks, so that they'll say analog, and then it become a digital, because analog clock use a quartz crystal within the mechanical system. So the periodic vibration takes place within the quartz crystal that shows the times, and the mechanism can be operated. After the analog, digital clock came, but digital clocks also have a greater accuracy comparing analog. But comparing a digital also have some time errors, some microseconds and some milliseconds errors are there. To avoid this, they brought the new clock, that is atomic clocks. So the atomic clocks use cesium atoms. Okay, atomic clocks use cesium atoms. So nowadays we are following the time Greenwich Mean Time. So India is forward. Comparing London, we are 5.5 hours earlier we are going. But Japan well in advance. அவங்க நம்மளோட ஃபார்வர்டில் போயிட்டுருக்காங்க. இப்போ நமக்கு எக்ஸாம்பிள் டைம் வந்துட்டு இப்போது ஆஃப்டர்நூன் 1 o'clock அப்படின்னா, ஜப்பான் நம்மளோட ஈவினிங்கே போயிருப்பாங்க. அவங்க ஈவினிங்கே வந்திருக்கோம். பட் லண்டனில் பார்த்தீங்கன்னா அவங்க 5.5 hours பின்னாடி இருப்பாங்க. இன்னும் இப்படி போயிட்டே இருக்கும். ஓகேவா? ஸோ அப்போ அவங்க ஃபாலோ பண்ண எல்லா டைமுமே அட்டாமிக் கிளாக்ஸ்லேருந்து மெஷர் பண்ணியிருக்காங்க. ஸோ அட்டாமிக் கிளாக்ஸ் யூசஸ் cesium atom. Cesium 133 atoms. So the cesium 133 atoms have a 2 hyperfine levels. This is a ground state. This is an excited state. This is a ground state atom. This is excited state energy level. So from the ground state to excited state, when electron transmission takes place, soon immediately the electrons will come back to the ground state, because the energy level won't be long for the excited state. Immediately the electrons will return back to the ground state. At the times it emits some kind of radiations. These emitted radiations have the frequency. The emitted radiation have the frequency. What is the frequency? The duration is 9192631770 periods. Avlo times adu vibrate ஆகும். Okay, so the definition of second is given from the duration of the frequency of 9192631770 periods of the radiations the radiation that carries to the transition of two hyperfine levels of what atom? Cesium atom. Transition of two hyperfine levels of cesium atoms, because atomic clocks uses cesium 133 atoms. Okay, so in the cesium 133 atoms, the energy level difference between the two hyperfine levels, the emitter frequencies have this much periods, so it have a greater accuracy. Even nanoseconds are less than a nanoseconds only, it have a error. So appo நம்ம ஆர்டர் பார்த்தோம்னா ஃபர்ஸ்ட் யூஸ் பண்ண clocks என்ன clocks? Sundial, sand clock, water clock. Sundial, sand clock and water clock. அதுக்கப்புறம் நம்ம யூஸ் பண்ணது it's analog. So analog mostly use quartz crystal. Analog mostly use quartz crystal. That's what in our wristwatches also have quartz, and wall clock also have a Q quartz அப்படின்னு சொல்லிட்டு. So because it is analog quartz crystal. After analog, the next digital watch comes. So the digital watch uses LCD display. Digital uses liquid crystal display, but this also have some error. But comparing analog, it is better. And comparing a digital, the best one is atomic clocks, because the atomic clocks uses what? Cesium atom, cesium 133 atom, so it have a greater accuracy. அப்போ இருக்கிறதுலையே the greater accuracy for atomic clocks. But atomic clocks விட digitalல கொஞ்சம் errors இருக்கும். Comparing it digitals, quartz have more error and this still have more error. So the definition of the quantity time, what is it? The physical quantity time, SI unit is second. So the second is the definitions brought from the atomic clocks. Okay, now we are moving to the fourth physical quantity, electric current. What is electric current? The fourth physical quantity is electric current. Okay, the SI unit of this physical quantity is ampere. It is named after the scientist Andre Marie Ampere. So the symbol is A, capital A. Whenever we use a scientist name as a unit, that should be mentioned with a capital letter. We know already the force is measured in Newton. So Newton is the unit for force. It is capital. Okay. Similarly, Kelvin, it is also a scientist name. So wherever we use a scientist name, mostly the symbol should be taken as capital letter. So here the SI unit of the current symbol is, SI unit of current is ampere, and the symbol also capital A. So how to define this ampere? It's a very simple thing. This definition, very deep detailed manner, you are going to learn in your 12th standard, but generally how to define the electric current. Let us take the two straight infinite parallel conductor. Let us take two straight infinite parallel conductors. So we have A and B, two conductors. It is infinite length. From that, the known segment we are taken. It is 1 meter length. Another one conductor also 1 meter length. So two current carrying conductor of 1 meter length separated at a distance of 1 meter in vacuum. Okay, in vacuum that exert the force. So the two parallel conductors carries a 1 ampere of current. The two parallel conductors carries the 1 ampere of current and the length of 1 meter. Okay, like this. See, imagine actually this is a chalk piece, but நீ எப்படி நினைச்சுக்கிறேன்னா இது ஒரு first conductor A, இது second conductor B. Both the conductors length are 1 meter. It was separated at a distance of 1 meter in a vacuum. ரெண்டுலயுமே current போகுது. So it's a parallel current, not anti-parallel current. It is a parallel current. It carries a 1 ampere of current. Then it experiences a force. Parallel conductor attracts. So the attractive force between the two conductor is 2 into 10 to the power minus 7 Newton per meter. அதனோட 1 meter lengthக்கு எவ்வளவு force experience பண்ணோம்னா 2 into 10 to the power 7 Newton, which means now we can define the current. The current is defined as two parallel conductor of 1 meter length are separated in a vacuum at a distance of 1 meter. Then it experiences a force of 2 into 10 to the power minus 7 Newton per meter. So this is a definition of electric current. So from this, the parallel conductor attracts. Similarly, anti-parallel conductor repels, but the force is same. Okay, either but mainly we consider parallel conductor attracts, anti-parallel conductor repels. So the definition of ampere is given, and very detailed manner you are going to learn this in your 12th standard. So in table column itself given all this definition just for your knowledge purpose, and you need not to memorize, but the definition will be you will be learning in the coming subjects and the coming years. Okay, so electric current is over. Then fifth one is temperature. So what is the temperature? Temperature is a physical quantity. Temperature is a physical quantity, and the name of the unit is Kelvin. We have a different unit: degree Celsius, Fahrenheit, and Kelvin. But Kelvin is the SI unit of temperature. Okay, even though we have a different temperature to measure, a different unit to measure the temperature, but Kelvin is the only SI unit to measure the temperature. So the scientist name, so the symbol is capital K, and the definition is Kelvin is the fraction of, I'll explain. Kelvin is the fraction of 1 by 273.16 of thermodynamic temperature of triple point of water. So what is the triple point of water? Because at 0 degree Celsius the water begins to melt from solid to liquid. Similarly, at 100 degrees Celsius the liquid state of water that vaporized into gaseous state. So that is a triple point of water. What is the thermodynamic temperature? It is 1 by 273.16 of thermodynamic temperature. We know 0 Kelvin, that is absolute temperature. So 0 Kelvin, this is the maximum lowest attainable temperature. இது வரைக்கும் scientistஆல reach பண்ண முடிஞ்ச maximum lowest attainable temperature is 0 Kelvin, which is equal to minus 273.16 degrees Celsius. இது imagine பண்ணி பார்க்க முடியுதா? Even human also cannot survive at this temperature. We are totally frozen. Okay, become very hard. Metal also become very hard at this temperature. இதுக்கு கீழே நம்மளால ரீச் பண்ணவே முடியாது. ஸோ இது வரைக்கும் தான் நம்மளால ரீச் பண்ண முடிஞ்ச லோவஸ்ட் maximum reached lowest attainable temperature is 0 Kelvin. It is absolute temperature. அதனோட 1 by fraction தான் என்னது? Kelvin. So Kelvin is the fraction of 1 by 273.16 of thermodynamic temperature of triple point of water. So this you will be learning in very detail in your thermodynamics lesson, second volume lesson. But now just only you try to know the definitions alone. Okay, moving to the sixth physical quantity, base quantity is mole, amount of substance. Sixth one is amount of substance. Amount of substance is defined, the SI unit of the amount of substance is mole, and the symbol is MOL. Symbol is MOL. So what is a mole? 1 mole of oxygen react with 2 mole of hydrogen that become a water. அப்படினு நம்ம படிச்சிருப்போம். So mole அப்படினா what is a mole? Chemistry mostly will use. Okay, molarities differ from it. Okay, so the mole, it is nothing but, see, we know the carbon 612 atom. அப்போ carbon 612 atom எடுத்திருக்கோம். So carbon 612 atomல 1 by 12 grams இருக்கு. So in carbon 612 atom 1 by 12th. Okay, and the 1 by 12th of carbon 612 atomல how many number of entities are there? Okay, that is equal to mole. Can you able to understand? We have a radiocarbon, we have the carbon 612 atom. In the carbon 612 atom la 1 by 12 gram la evlo number of how many entities the number of entities, that is elementary particles, number of entities present, that is defined as amount of substance. So amount of substance is a physical quantity. The unit is, the name of the unit is mole, symbol is MOL. So the definition is, we have a carbon 612 atom. அந்த கார்பன் 612 ஆட்டமில் எவ்வளோ கிராம் எடுத்திருக்கோம்னா 1/12 எடுத்திருக்கோம். அதாவது புக்கில் எப்படி மென்ஷன் பண்ணியிருப்பாங்கன்னா 0.0012 கிராம் அப்படின்னு எடுத்திருப்பாங்க. am I right? yes 0.012 gram of carbon 612. atomic number is 6, mass number is 12. so இதில் எவ்வளோ entities இருக்கோ, the total number of elementary particles irukko, that is equal to mole. Okay, then the seventh physical quantity, we have a 7 fundamental quantity. No, so far we have discussed 6. Now we are moving to the 7th fundamental quantity, that is luminous intensity. The 7th one is luminous intensity. What is the luminous? The substance which emit their own light. No, that only we are saying as a luminous, like sun, stars, burning paper, fireflies, many things we can say. So whatever the substance, when it burns, that emits a light or it gives their own light, is called luminous. So similarly, the luminous intensity is a physical quantity. The name of the luminous intensity is candela. Candela. So CD, small c, small d, it's a symbol. What is the definition? Imagine there is a monochromatic source, which means the source which emits only one kind of radiations or one kind of color. That is called a monochromatic source. So a monochromatic source, mono means single, chrome means color. A monochromatic source that emits the frequency of 540 into 10 to the power 12 hertz of radiations till it completely burns or till it completely emits the radiations. There is a monochromatic source. So the monochromatic source, it begins to burn from the beginning till it completely melt or till it completely emits. Just we take a candle, we start to light the candle. Candle எரிய ஆரம்பிச்சதுலேருந்து எரிஞ்சு முடிக்கிற வரைக்கும் how much amount of radiation அது எமிட் பண்ணியிருக்கோ அதுதான் எதுக்கு ஈக்குவல், கேண்டலாவுக்கு ஈக்குவல். அது கிளியர்? ஸோ அப்போது அப்படி டோட்டலாக அது எரிஞ்சு முடிகிற வரைக்கும் எவ்வளோ ரேடியேஷன்ஸ் கொடுத்துருக்கோம்னா 540 into 10 to the power 12 hertz. Okay, so totally we have discussed the 7 fundamental quantities. I hope you are clear about this 7 fundamental quantities. You need not to memorize these definitions, just try to understand how what is the meaning of each definitions. But all these definitions you are going to learn in your coming 11th standard as well as the 12th standard. Okay, இதில் எதெல்லாம் நீங்கள் பார்ப்பீங்க அப்படின்னா 12th பார்ப்பீங்கன்னா எலக்ட்ரிக் கரண்ட், ஆம்பியரோட definitions, and then thermodynamic temperature, Kelvin வந்து நீங்கள் செகண்ட் வால்யூமில் பார்ப்பீங்க. Then candela also you will be learning in your 12th standard. Remaining thing you will be learning in your 11th itself. Okay, I hope you are clear about this definitions. Next we have moved to 2 more quantities we have apart from the 7 fundamental quantities. We have 2 more quantities. One is plane angle, another one is solid angle. Listen, what is a plane angle, what is a solid angle? One is a plane angle, another one is solid angle. So plane angle mostly applicable for 2D object. Example, let us take a sheet, a circular sheet. The circular sheet have the radius r from the center. Okay, the circular sheet have the radius r. The radius remains constant throughout the 2D object. So this is a sheet of paper. We'll take a small piece. We'll take a small piece from A to B. We'll take a small piece. So this shaded portion is a small arc. Okay, in this arc, the AB gives arc length. This is arc length. and this arc length here, it create an angle. That angle is theta. So now we can define it, the plane angle. So what is a plane angle? It is an angle subtended by, what is the plane angle? The plane angle is nothing but, yes, so the plane angle is the ratio of the length of the arc to the radius. The plane angle is denoted by the letter theta. Plane angle is a ratio between, plane angle is a ratio between, plane angle is the ratio between arc length to radius. Plane angle is a ratio between arc length to radius of the arc circle. So plane, but this is a small angle only, so we need not to use theta, d theta. Similarly, the arc length, this arc length is denoted by ds. Already we know the radius remains constant. So the plane angle is the ratio between arc length. What is the arc length? ds to the radius of the circle. Okay, so this is the formula, d theta is equal to ds by r. If you want to know the arc length, what is the formula for arc length? So arc length ds is equal to d theta into r, and the SI unit of this plane angle is radian. The SI unit of this plane angle is radian. So this is the plane angle, the SI unit of this plane angle is radian. So the symbol is RAD. Okay, so this is the plane angle. I repeat once again, plane angle is very simple. We have a sheet of paper, but this is a square shape. Now I made it as a circle. I made this paper into circle. So anyhow, we have circular sheet of papers. So in this circle sheets, small arc will take. So the small arc is, this is the arc, and the arc length is AB. So from A to B it makes a small angle d theta. So what is the plane angle? The plane angle is a ratio between the arc length to the radius of circle. What is the arc length? ds is the arc length and radius of circle is r. So ds by r, and the SI unit of this plane angle is radian. So it is mainly for 2D. Okay. Next we are moving to solid angle. So moving to the next one more quantity is solid angle. Plane angle is applicable for 2D, solid angle is applicable for 3D object. It is same like a plane angle but small changes alone. Okay, so let's check. Imagine we have a huge watermelon. Okay, the watermelon, its exact spherical shape you imagine. It is a spherical shape watermelon. From that a small portion alone you have cutted and you take out. Okay, so இப்போ வாட்டர்மெலன்ல இருந்து ஒரு சின்ன பீஸை மட்டும் நீ கட் பண்ணி எடுத்துக்கிற, அந்த பீஸ் எப்படி இருக்கும்? Imagine. So I cannot draw the 3D exactly, but this is the three-dimensional sphere. From the three-dimensional sphere, like example watermelon, from that small portion you are taken. So how the small portion looks? நீ இப்போ எடுத்த இந்த ஒரு small portion எப்படி இருக்கும்? See, so the small portion looks like this. So this is three-dimensional. Okay, in this three-dimensional, this is a area. And this curved surface area, this is a curved surface area, and here it have an angle. What is an angle? D ohm is the solid angle. So plane angle is a 2D, solid angle for 3D. So from the 3D, so to draw the diagram is very simple. I repeat once again, listen carefully. This is a solid angle. So this is the surface, the outer surface. This is the edible portions. Okay. So from the center, we have taken the small piece. So here it made an angle, solid angle, and this is the area dA. So how to define the solid angle? Solid angle is defined. The solid angle is defined, that is d ohm. D ohm or omega. D omega is the ratio between this area of the arc length to the square of radius. So it is a ratio between area of arc to the square of radius. Square of radius. What is the area of the arc? The area of arc is dA to the square of radius, that is dA by r square. Therefore the solid angle d omega is equal to ratio between area of the arc to the square of the radius, and the SI unit is steradian. For plane angle it is radian, and for solid angle is steradian. So steradian, and we have a symbol also. The symbol is steradian, SR. The symbol is SR. For plane angle it is radian. Plane angle we use radian, and for solid angle it is steradian. Okay, plane angle for 2D and solid angle for 3D. So இது எப்படி இருக்குன்னா, ஒரு வாட்டர்மெலனில் ஒரு போர்ஷனை கட் பண்ணி எடுத்துட்டோம். நம்ம செக் பண்ணுவோம் இல்லையா கடையில், அந்த பழம் நல்லா இருக்கா இல்லையான்னு. ஸோ மேலே வந்து நம்ம இப்படி கட் பண்ணி எடுப்போம் ஒரு பீஸ். ஸோ தீஸ் full of edible fleshy portions. This is the outer surface, that the skin of the watermelon. The skin of the watermelon, how it looks, it's green in color or some other color. Okay, so in this curved area, it is a ratio to the curved area to the square of the radius. Everywhere the radius remains constant. Okay, so everywhere the radius remains constant. So the solid angle is the angle created between angle created between the surfaces, and it is equal to the ratio between the area of the arc to the square of the radius. Okay, because area means side into side, so the square of the radius comes. Thank you.